Hey everyone, so I've got another synthesis challenge for you. Check out this substrate. We've got these two benzene rings, and then we've got to put a bunch of stuff on it. So we know we're putting things on benzene rings, probably going to be doing some electrophilic aromatic substitution, maybe some other reactions as well. So this is a little bit tricky, but they're, all the reactions are well known. So take a few minutes and see if you can get this one. Okay, so let's take a look at this. We've got three functional groups that we've got to get on there. We've got the amino group with the acetyl group with the acetyl on there. We've got the bromo, and then we've got the hydroxyl. So what are we going to do? We don't really know of a way to get an amino group or a hydroxyl group onto a benzene ring by electrophilic aromatic substitution. Bromine we can do. We know we can brominate. So that one we know. But what else can we do? Let's say we want to get one of these things on there. Let's start with nitrogen. Well, we do know how to nitrate, right? We can get a nitro group on there. So let's do that first, just so we can get that nitrogen in place. So we're going to do HNO3, H2SO4. We remember these conditions. So we've got, I'm just going to use the little circles for the benzene rings because we're going to be drawing a lot of them. Okay, so there is our NO2. So we've got the nitro group on there. Now let's try to get something else on there. Now here's the interesting part about this. The nitro group is going to inform what we're going to be doing. So we know the nitro group is deactivating, so it's going to make it harder to do more reactions on this ring. So let's try to do a reaction on the other ring. We want the hydroxyl on there, but we don't know how to do that. Let's just get some oxygen-containing functionality on there at the very least. So what if we do some Friedel-Crafts chemistry? Let's do a Friedel-Crafts acylation. We need that aluminum trichloride catalyst. And so here's what we can understand about the regiochemistry. This nitro group is deactivating over here. And so, by the way, to get the nitro group on here, the reason we put it at this location is that we can consider this carbon an alkyl group that is acting on both rings, right? And so we know alkyl is ortho-para directing, and so sterics will cause things to prefer the para location. And so we put the nitro right here because it's para to alkyl. Right, that's why we put that there. And now we're going to do the same thing here. We're going to do Friedel-Crafts acylation. We're going to do it on this ring, the lower ring, because the upper ring is deactivated from the nitro group. And again, we're going to put the incoming electrophile on the carbon that is para to this alkyl. So this CH2 right there is determining all of our regiochemistry for us. So let's draw that. We've got our first ring there. That's not so good. With our nitro group, and then now we have this situation here. Okay, so what are we going to do next? Now, we do know that we need to go from the nitro group to amino, so we've got to reduce. We're going to need to do some hydrogenation there. But the thing is, we've got this carbonyl, and we don't want to mess with that while we're doing that. And so we are going to need to protect. We're going to need to protect this carbonyl. And we know our classic way of protecting ketones. We've got the vicinal diol, and we are just going to pop that on the carbonyl. So here is our nitro, and now we have this situation. Right, that diol is on there now. So now our carbonyl is safe, and now let's address NO2, right? The reason that we need to do this now, we need to mess with this nitro group, is because we need the bromo group on there, but nitro groups are meta-directing, right? So not only are they deactivating, which would make it hard to brominate on this ring, they're also meta-directing, so we would not get the regiochemistry we want. So we need to do this now. And with our carbonyl safely protected, we can hydrogenate over palladium. Hydrogenation over palladium is going to get us to the amino group, to the NH3, and then let's react with acetic anhydride, and we will get what we want there. Whoops, we're going to get NHAC. Write that a little cleaner. And we still have this situation here. Okay, so now what can we do? Now we can put the bromo group on there, because now we've changed that nitro group into this group here. So not only is this now activating, right, because the nitro group, remember those oxygen atoms, they're pulling up the electron density, they're destabilizing the rhenium ion intermediate by resonance. So, but now we've got this nitrogen, that lone pair is getting dumped into the ring. So this is activating and therefore orthopara directing. So orthopara directing, we can now brominate. And a couple of things here. Number one, we can be confident that it is going to go on this top ring because there's nothing activating this ring, but this ring is being activated by the nitrogen atom. And because it is orthopara directing and the para position is occupied, these ortho positions are identical because of the ability of this sigma bond to rotate. So there's no worries here about regiochemistry. We absolutely will get that bromo group exactly where we want it. So let's draw this thing here at the bottom, and here is our NHAC, and now we've got bromo. We've got bromo. So the top ring is done. Top ring is done. So now we got to mess with this. So let's deprotect. Let's deprotect and get back our ketone. It's getting a little cramped down here, but hopefully you guys don't get confused. You see what I'm doing? Okay, so this is maybe the trickiest part here. This is all, right, we know how to nitrate by EAS. We know Friedel-Crafts acylation. We know how to protect a carbonyl. Hopefully we know how to convert the nitrobenzene to aniline or an aniline derivative. That's just a hydrogenation, and then deprotect. Now we're here. This is a little tricky. We want to go from this carbonyl. We need this hydroxyl right there, right? So how are we going to get, right? We need oxygen connected to that benzene ring directly instead of this carbon right here. So here's a trick. We're going to use, we did learn this. We learned Baeyer-Villiger oxidation over in my organic chemistry series. So we're going to use, we're going to need a peroxy acid. So let's use this one here, the trifluoro variety. Right, so we've got it's the carbonyl OOH. There's that extra, it's not a carboxylic acid, we've got the extra oxygen there. And if we remember the Baeyer-Villiger oxidation, we know we're going to insert an oxygen atom adjacent to that carbonyl. So what's happening is we're going to insert an oxygen atom in that bond right there. So let's draw our ring. And so we've got boom, and then boom, boom, boom. And then the rest of the molecule is as it was. So what's useful here is, so we've got that oxygen there, right? That oxygen is going to be the hydroxyl oxygen, and now we can just hydrolyze. So just a little, we're going to just do hydrolysis, right? Hydroxide is going to attack the carbonyl, and it's going to kick off the rest of the molecule, which is the product. So I'll just write product. I'm tired of drawing this molecule so many times. But there it is. So it can be tough. I think that EAS stuff is a really good test of retrosynthetic analysis because you have to devise a sequence, right? You have to know what the things you're putting on there, are they activating or deactivating? Are they ortho-para-directing or are they meta-directing? And then this one had an extra little wrench in it in that two of the groups are not groups that are commonly attached. Or, we don't have EAS reactions to put on amino groups or hydroxyl groups, so we had to get clever. Now, it's maybe not that hard to guess that you're going to go nitro first and then hydrogenate. That part was a little more obvious, but this bit with the Baeyer-Villiger is a little more clever. So don't feel too bad if you didn't get that. That was a little trickier to see, but it was a good strategy to just insert some oxygen-containing functionality there, because that is what allowed us to do the Baeyer-Villiger. So once again, we nitrated by EAS, and that went to the, well, it didn't matter, right? It's identical, but it went para to the CH2. Friedel-Crafts acylation was done to the other ring because NO2 is deactivating. We protected the carbonyl. That allowed us to then go do our business hydrogenating the nitro group to get to the amino group derivative. Then we were able to brominate because we went from the deactivating meta director to the activating ortho-para director. So we got the bromo group right where we wanted. Then we could deprotect, and then we did our Baeyer-Villiger oxidation to get that oxygen atom on there, and then hydrolysis gave us our product. So that was a nice fun one, and that's it.
Thanks for watching, guys. Subscribe to my channel for more tutorials. Support me on Patreon so I can keep making content. And as always, feel free to email me, ProfessorDaveExplains@gmail.com.